In this lecture, I'll talk about addressing in the internet. So IP addresses. The IP address is a TCP IP, really IP, addresses a machine, a host, using an IP address. So an IP address is a unique number for all machines on the internet. This isn't always true, but this is mostly true. We won't talk about the exceptions too much to that rule. So IP version 4, IPv4, you may have heard of, it uses 32-bit addresses. This is the standard right now, 32-bit addresses. So that's 4 numbers that are 8 bits each, separated by periods. That's usually how it's notated. So 192.0.0.0. Since each number is an 8-bit number, it goes up to 255, so 0 to 255. So you get 4 numbers in sequence like that that are in the range 0 to 255. So that's what your standard IP address looks like, IPv4. Now, often this IP address is chopped up into 2 parts conceptually. There's a network address, which is the address that is common to all of the machines that are inside your local network. So the high bytes of the address. So depending on how big your local network is, like UCI's network, probably the first byte is common to every machine in UCI's network. And then the low 3 bytes are different depending on which machine you are in the network, something like that. So there's the network part of the address, the high bytes. Then the host address are the low bytes, and those are unique to every host in the network. So that's an IP address. It's basically these 4 bytes put together, standard IP address. Now IPv6 is the new IP. So the problem that you have with IPv4, which is mostly in use, is that it's 32 bits long, right? It's only a 32-bit address. IPv6 uses 128-bit addresses, right? Much longer addresses. So the 32 bits is limiting. It limits the number of addresses that are available, right? Because IPv4 can only support up to 2 to the 32 different addresses. The internet will exceed this. In fact, it does exceed this number. So 2 to 32 is, if I remember off the top of my head, I think it's about 4 billion addresses, which used to seem big, but now you have more than 4 billion machines out there that are networked. I mean, especially with Internet of Things, every little device has its own address, right? So my phone, everything has an address. So that's really not enough addresses to satisfy all the machines that are out there. So what do you do? Well, IPv6 is supposed to be a solution to that. Then IPv6 gives you 2 to the 128 addresses, which is a much bigger number. Now, in the meantime, what people do is they do other tricks. Basically, they remap addresses, so you share IP addresses in a funny way that we won't cover in this class. But that's what IPv6 is for. And eventually, we have to go to it. And some people are adopting it, but generally, I would still say IPv4 is dominant. So IPv6 integrates security also. So you know how we use Secure Shell to have secure communications. We talked about that in a previous lecture, right? Because Secure Shell puts encryption in there. It encrypts the messages in transit. Well, IPv6 does that by default, meaning you wouldn't have to use Secure Shell. It's already encrypted. So it uses IPsec, which is a protocol which performs encryption of communication data in transit. So IPv6 is also more secure than IPv4. It also incorporates several other changes to the header. Some header fields become optional and so on. But it's not widely adopted yet. Still, people are using IPv4. Ports. Okay, so every host has this IP address. Every machine has this IP address. It's on the network. But TCP and UDP, these protocols use port numbers to specify particular networked applications on a machine. So remember how TCP UDP is process-to-process communication. So each process needs to be assigned to an individual port number. So what happens is port numbers are assigned to each network application layer protocol. So what does that mean? Let's take, for instance, web traffic, okay? Web traffic uses a protocol called HTTP. HTTP, which basically defines web traffic, that is assigned to port 80. So port 80 is known as the port where web traffic is going to be. And so every web browser, it sends, when it's talking to a server, a web server, it sends data to port 80. And when a server is sending responses back to the web browser, it sends it on port 80. So the web server has to listen on port 80, and it sends back data on port 80. So port 80 is known for web traffic. And so This happens with all networked applications. They're associated with a particular port, like Secure Shell. Secure Shell is on port 23, I think. But you can Google this. You can Google a list of all these well-known ports that are associated with different internet-based applications, different network applications. So these ports are assigned to each one of these protocols. And so there's like HTTP is a web protocol that's on port 80. Secure Shell has its own protocol that's on port 23, and so on. Now, port number is a 16-bit value, and it's contained in the TCP and the UDP headers. So it's only 16 bits, but that so far has been enough bits. 16 bits gives you 64,000, or really 64K, which is like 65,000 addresses, 65,000 ports, which has been plenty. There's more than enough ports right now. Thank you.